All right, welcome class. So, in our last few sessions, we've really been laying down the foundational mathematical concepts. Today is where we bridge that gap. We're moving from abstract theory to real, tangible business strategy. We're going to focus on one of the most powerful tools in your entire arsenal, and it's one that looks deceptively simple, the linear function. We're going to deconstruct how a simple straight line can bring incredible clarity to the very complex, very dynamic relationship between what a company decides to do and how its customers behave.
So, let's ground this in a scenario that's not just practical, but one that every single one of you in this room is likely going to face in your career. I want you to imagine, you've poured months, maybe even years, into research and development. Your team has done it. They've perfected a new product. It's ready to go. Now, this is the moment of truth. You've got a dozen huge decisions to make, right? Marketing budgets, distribution channels, branding, the list goes on. But I want you to really think about this. What is the single decision that is going to determine the entire financial future of this venture?
That's it, the price. You see, pricing is so much more than just a simple cost-plus calculation. It's the main strategic signal you send out to the entire market. Yes, of course, it dictates your revenue, but it also fundamentally defines your brand's position, it shapes how customers perceive you, and honestly, and this is no exaggeration, it can be the only thing that separates a massive success from a really costly failure. This is exactly where we move beyond a simple gut feeling. Mathematics. Mathematics gives us the rigorous framework we need to make this decision with analytical precision.
Okay, so how in the world do we tackle this huge task of setting the perfect price? Well, the whole process has to start with understanding our customers on a deep level. And it's more than just understanding them. We need to quantify their behavior. We need to create a mathematical model of exactly how they're going to react to the prices we set. And to do that, we're going to start with a really foundational economic concept, the linear demand function.
Now, when you first look at this equation, QD equals A minus BP, I know it might seem pretty basic, but I really want you to appreciate just how elegant it is as a model of how markets behave. Think about it. It takes the complicated, often emotional decisions of millions of different people, and it boils them down into a clear, formal relationship between the one thing we can control, the price, and the quantity they're going to buy. So let's do a really detailed breakdown of every single component here to understand the story this little equation is telling us.
All right, let's start with QD. This stands for quantity demanded. In mathematical terms, this is our dependent variable, meaning its value depends on the other parts of the equation. It's the outcome we're trying to predict. But in business terms, this is the million-dollar question, isn't it? At any given price, how many of these things are people actually going to buy? Getting this number right is what leads to accurate revenue forecasts, efficient production schedules, basically a well-run business.
Next up, we have P for price. Now this is our independent variable. It's the primary lever that we, as the business managers, have direct control over. We can raise it, we can lower it, and every single change we make is going to have a direct, and as we're about to see, a predictable impact on the quantity demanded. The whole point of this analysis is to figure out the exact nature of that impact.
Okay, now let's turn to the constants in the equation, starting with A. Mathematically, you know A as the y-intercept. It's the point where our line crosses the vertical axis. In a business context, though, this has a really fascinating and crucial meaning. It represents the absolute maximum theoretical demand for your product if the price was zero. I want you to think of A as the total market ceiling. It's the number of units people would just take if they were free. This constant captures all the non-price factors that drive demand, things like brand loyalty, market hype, just the basic need for the product.
Now let's focus on what I think is the most important part of this equation for any strategic analysis, the slope, represented by negative b. And please, pay very close attention to that negative sign. That single minus sign is the mathematical version of one of the most fundamental laws in all of economics, the law of demand. All other things being equal, as the price of something goes up, the quantity people want goes down. The letter B itself, that number, it quantifies the strength of this relationship. It's the measure of how sensitive your customers are to price. A big B means you have an elastic market. A small price increase will cause sales to plummet. A small b, on the other hand, means you've got an inelastic market. You can raise your prices and you won't lose that many customers. Understanding B is really understanding your own pricing power.
So, we've just built a model for the consumer side of the market. But remember, that's only half the story. A market is really a conversation between two groups. So now we have to turn the camera around and model our own behavior as the producers. We need a mathematical way to represent our own willingness and our ability to supply this product to the market. And this is the equation that does it. QS equals C plus DP. This represents the producer's point of view, and we call it the linear supply function. Now, structurally, it looks a lot like the demand function we just picked apart, but I want you to immediately notice the critical difference, that plus sign. That seemingly tiny change from a minus to a plus completely flips the logic and represents a totally different set of economic motivations.
Here, Qs stands for quantity supplied. This variable is all about our operational reality. It answers the question, at a certain market price, how many units is our company both willing and able to make and sell? And this number isn't just pulled out of thin air. It's determined by the cost of our raw materials, our factory's capacity, our supply chain, and of course, our overall goal to make a profit.
And that brings us to the slope of the supply curve, which is plus D. That positive sign is the mathematical way of showing the core incentive for any business. Think about it. As the market price P goes up, our potential profit on every single unit we sell also goes up. That gives us a really powerful direct incentive to supply more. It's the reason we might authorize an extra shift at the factory or pay more to expedite a shipment of materials. The coefficient D tells us exactly how responsive we are to those price incentives.
Okay, let's just take a second and recap. We have now modeled two opposing forces. On one side, you've got consumers who are driven by the law of demand. They want to buy more when prices are lower. On the other side, you have us, the producers, driven by the profit motive. We want to supply more when prices are higher. The entire purpose of a market and the real analytical power of this model is to find that one single precise point where these two opposing forces are in perfect balance.
And we call this balancing point market equilibrium. Now, I really want to stress this is not just some abstract theory. It's the state that a competitive market naturally moves towards. It is the one unique combination of price and quantity where the number of items that producers want to sell perfectly matches the number of items that consumers want to buy. The market is cleared. There's no wasteful surplus, there's no frustrating shortage, and the best part is we can find this exact point using the algebra you already know. So the logical foundation for finding this equilibrium point is actually quite simple. It happens at the point where quantity demanded is equal to quantity supplied. So if QD equals QS, that means we can set their two expressions equal to each other. A minus BP has to equal C plus DP. And that right there is the key step, where we translate a core economic idea into a solvable algebraic equation. Let's walk through the algebra here, step by step, because it's so important to understand the logic. Okay, step 1. We set the two equations equal to each other. A minus BP equals C plus DP. Our goal now is to get P all by itself. So for step 2, we need to gather all the terms with P on one side and all the constant terms on the other. So we'll add BP to both sides, and we'll subtract C from both sides. That gives us A minus C equals DP plus BP. Now look at the right-hand side. You can see that P is a common factor, right? So for step 3, we just factor it out. That leaves us with A minus C equals P times D plus B. And finally, for step 4, to get P alone, we just divide both sides by that term in the parentheses, D plus B. And that gives us our final formula for the equilibrium price.
And there you have it. The formula we end up with gives us P star, which is what we call the equilibrium price. It is absolutely essential that you see this not just as the answer to a math problem. This is the optimal market clearing price that we derive directly from our models of consumer behavior and our own producer incentives. It's the one price that perfectly balances the conflicting desires of everyone in the market. But hold on, we're not quite done. Knowing the perfect price is only half the battle. Your operations team, they need to know how many units to actually make. So to find the equilibrium quantity, or Q star, we take the value we just found for P star and we plug it back into either the original demand or the supply equation. It doesn't matter which one because, by definition, at this one special price, quantity demanded equals quantity supplied. So both equations will give you the exact same answer. And that answer, Q star, that's your production target. This table shows you exactly why this equilibrium idea is so critical from a strategic point of view. Let's just think about what happens if we get it wrong. If we set our price above P star, well, our incentive to supply is high, but not many customers are buying. The result? A surplus. You've got warehouses full of unsold stuff racking up storage costs. On the other hand, what if we set our price below P star? We create a shortage. Demand goes through the roof, but we're not willing to supply that much. You get empty shelves, frustrated customers who might go to your competitors, and a ton of missed revenue. Equilibrium is the only point of perfect efficiency in the market. As business students, getting the right number is really just the baseline expectation. But what separates a good analyst from a true strategic leader is the ability to understand the deeper meaning behind that calculation. It's about knowing the common mistakes people make and knowing how to translate a mathematical result into a real-world business strategy. So, let's shift gears now from just calculation to strategy.
These are the mistakes I see over and over again, both on exams and in real business case studies. The most critical one, the one that's conceptually the most damaging, is confusing the signs of the slopes. If you model your demand slope as positive, you are working with a model that fundamentally breaks the laws of economics. It's an instant logic failure. Other common errors are just simple algebraic mistakes when you're rearranging the formula, a careless slip that makes the whole result wrong. And a classic one, you do all the hard work to find P star, and then you just forget to do the final step and solve for Q star, leaving your operational team with an incomplete plan.
So let's be perfectly clear about what this model is and what it isn't. It is not a crystal ball. The real world is way more complex and dynamic than this simple straight line. Consumer tastes change, a competitor will launch a new product, a new regulation will increase your costs. So what this model gives you is not a final definitive answer. What it gives you is a powerful tool for strategic thinking. It gives you a rational, data-driven baseline to build your pricing strategy from. It's the logical foundation, and then you can layer on top of that your judgments about marketing, competition, and everything else happening in the world.
And this, right here, is why this material is so critical for your careers. Someday, when you're in a boardroom presenting a strategic plan, you can't just say, well, my gut tells me we should price this at $49.99. You'll be expected to give a rigorous justification for that number. Understanding this framework lets you build a case that you can defend. It gives you the power to model different scenarios, to anticipate how a competitor's price cut might affect your equilibrium, or to calculate how a new tax will shift your supply curve and force you to change your price. This kind of analytical fluency, that is your strategic advantage.
So I'm going to leave you with one final question to think about as you prepare for our next session. The model we've built today is static. It assumes everything stays the same, but real markets are always changing. So I want you to think about this. If a big new competitor enters your market with a similar product, how does that event change the variables in our equations? Does it affect A, the total market size? Does it change B, the price sensitivity of consumers? How would you adjust this model to reflect that new reality? Being able to answer that question, well, that's the next level of strategic analysis. Thank you for your attention today.